And after that, I'm done.
Alright. Well, we're going to be solving Alright, so when you're solving exponential equations, one way, which is probably the easiest way to solve an exponential function, is to get the same base. Okay? If you notice you have a base of 4 and a base of 16, they're not the same. But isn't there a way that you can rewrite 16 to have the same base? Say again. So this will be 4 squared, and you'll still have that x minus 3 at the top. Over here you'll have x plus 2. And I already talked about this. When you have the same bases on opposite sides of the equal sign, they cancel, so you're just left with the exponents to solve for. And since we're looking for x, this is nothing but a linear equation that you solve. What do you do to that 2? Distribute. So you get 2x minus 6. Get your numbers to one side, variables to the other. So that'll be a 2 equals x minus 6, and then x equals 8. Simple enough, okay? And you can always check by doing what? To the original. What's 8 plus 2? 10. And then what is 8 minus 3? 5. Now I know you're like, well, that's not the same thing. Well, again, how can you rewrite 16? And what do you do to the 5 on the outside? Multiply to the 2, and they're equal. Okay? So that's that one. There you go. Let's look at this one. Isn't there a way I could rewrite this so that they have the same base? if you have learned your powers like I asked you to, you should know your powers. 3 to the 4. Very good. So 81 is 3 raised to the 4th power. And I know you might be thinking, oh, but these are fractions. How do I do this? It works the same way, okay? Because since the numerator is a 1, okay, and your fraction has an exponent of being applied to it, how do you apply that exponent? I'll start there. How do you apply that exponent? Yep, you definitely have to multiply that 2/3 by the 4 on this side. What about the 1? Does the 1 get applied to exponent too? Yep, so it will be 1. So you'll have 3 to the 4 times 2/3. What's 4 times 2/3? You get fast fraction. 8 over 3. And what about over here? What would that be? 1 over what? 3 to the n. So, if you notice, aren't these the same bases?
Yep.
So all you do is cancel out. So n equals 8 over 3. Simple, yeah? Okay? I want you guys to look, do the next one on your own. So yes, your answer should have been 2. What was the base that you wrote? 5 squared with the x plus 2 there. And so then you'll just set your exponents equal to each other. And yes, that is how you get 2 with a little bit of algebra. Don't forget to distribute the 2 to the x and to the 2. All right, back to me. So you're going to solve 2 ln of x equals 18 and round to the nearest 100. So you will need your calculator for this one. Now, these are a little bit different because one, you're dealing with the natural log. What goes with natural log? E. So the main thing is to undo a natural log, you take the e of both sides. To undo e, you take the natural log of both sides. But in order to do that, you have to get it by itself. So I got to get rid of that 2. What am I going to do? Divide. Because that's 2 times the ln of x. So if I divide, I get rid of it. So I have the ln of x equals, and then to get rid of the ln, to get the x by itself, you're going to raise both sides to the e. And the reason why is because what's e raised to the ln? 1. This goes away and you're just left with x. And you'll have e to the 9th on the other side. Which is what? Approximately. And then round to the nearest 100 would be 0.08. Here we go. Okay? bad, right? Main thing is when you're given either a natural log or a log, you want to get it by itself so that way you can either take the e of both sides, etc., etc. Let's look at another one together. What do you suggest? I got to solve for x. Got to get log by itself, which means I need to do what to get it by itself? Subtract 7. So I have a negative 3 log 10x equals 6. Divide by a negative 3. Because again, I got to get my log by itself. That's going to be a negative 2. Now here, this one's different. Huh? This one, you can actually write this in exponential form to help you solve. What's your base here? What's your base for your log? 10, because there's nothing there, which means it's automatically a 10. Common log, which means that to write this in exponential form, it's going to be 10 raised to the negative 2 equals 10x. Okay, remember it's your base raised to whatever it equals. Okay? And then we just solve this. Okay, before we do. Can't have me negative exponents, gotta make it happy.
1 over 10.
1 over 10 squared. What's 10 squared? So this is 1 over 100 equals 10x. How do I solve for x? How do I add a fraction within a fraction? Keep, change, flip. Keep, change. When I flip that, that turns into, which is now this one was a little bit of algebra heavy, but you know, works the same way. A little bit of exponent work, a little bit of old school keep, change, flipping. But the main thing was you had to get log by itself in order to solve it. Okay? All right. One more together, and then I'm gonna then you're gonna try one on your own. Okay? We're gonna solve log base 5 x to the 4th equals 20. We're gonna round to the nearest 100. Okay? So we could definitely put it in exponential form. It's going to be 5 to the what? 20th equals x to the 4th. And whoo, good thing this says round to the nearest 100 because, wow, 5 to the 20th, that is huge. That is huge. But when I solve for x, we're going to do what? How do I get x by itself? Take the 4 through to both sides. Who remembers how to do that in their calculator? You do have to hit math. Before you hit math, you have to type something in first.
You want to divide by.
See?
You hit 4
You type 4,
math.
then you go to math.
5.
Okay?
And you type in the number you want.
4, math. Go option 5, yep. And then you type in the number, which was 5 raised to the what? 20th power. Woo! 3125. Yep, 3125. There's another way you can do it though, just in case you forgot how to do that. Apply your property. There's an exponent up here. What can I do to that? What can I do to that exponent? Come on now. Property we just went over. Power property. You can expand it by bringing it down to the front. 4 log base 5 x equals 20. Divide by 4, and now at least this way it is a little bit smaller. Right? It's an exponential form. It's going to be what? 5 to the 5th equals, and that's a little bit easier to do 5 raised to the 5th versus trying to remember that 4th root. I press 4, then math, and on your own. Okay? Then we could have brought that down and multiplied it by the 2 to get 6. This way you wouldn't have to use your calculator. Divide both sides by 6 to get 3. Write it in exponential form. 2 to the third is. Okay. So these are just a couple of different ways that you can solve a logarithm, guys, or an exponential. Okay? This one, it's a little bit different, a little bit more involved. Okay? So when you see something like this, log base 2 of 5 equals log base 2 of 10 minus log base 2 of x minus 4. What do you think? What's something that could help me in solving this? You know it's division. So this side over here, how do I write this? And since I know it's division. Log 2, 10 over x minus 4. Yes. Over here you have a log base 2 of 5. And we talked about this. When you have the logs on the same side with the same base, you can do what? Cancel. And only can you cancel here. You have one log on the left, one log on the right. We wouldn't have been able to do that from the very beginning. It has to be one log. Okay, so that's why you use the properties to condense it. So then when you cancel it out, you just get a simple 5 equals 10 over x minus 4. Can you guys finish solving that out for me, please? X equals 6. Okay, because you multiply both sides by x minus 4, distribute over the 5, and you get x equals 6. Good stuff. Okay? Ooh, I want you guys to write this one down in your notes. I do want you guys to write this down in your notes. Okay? So, how can we start this problem out? It says log base 5 of x squared plus x equals log base 5 of 20. How can we start this one out? I have one log on both sides with the same base, so the logs can cancel out, and I'm left with x squared plus x equals 20.
Subtract the 20 and factor.
Yes, subtract the 20 over factor. I knew. Due time. Yeah, we would recognize that and be like, yeah. Factor this out. How do these factor? Positive 5 and negative 4. Okay. Then you'll set both factors equal to 0 and x equals 4. Okay? Now one thing, guys, I've been doing something wrong. What have I not been doing the last couple of problems? I have not been checking. I checked the first one, I've just been rolling ever since. Probably because I'm running out of time. But you want to make sure, especially with log equations, that you check. Because what can you not take the log of? A negative number. So if you get a solution and you plug it in and you end up getting the log base 5 of a negative number, it's not a solution. But luckily enough, when we plug in negative 5, what's negative 5 squared?
25.
Minus 5.
20.
So it works because it equals the right side. And when we plug in 4, what's 4 squared?
60.
Plus 4.
20.
So it works out. This one worked. Will they always work?
No.
No. So do check, guys. Please check. Can you do this one, please? On your whiteboard. So if you get A, that means you said that only one worked.
Yeah.
Okay, what you have to do here on the on this side? Condense it. Log 3 of what? X times x minus 2. Since you had the same log on the same side, you would have had 15 equals x squared minus 2x. Subtract 15 over factor, and you would have gotten x equals 5 and x equals negative 3, but why'd you say negative 3 didn't work? When you plug in negative 3 there, that makes it not possible, so yes, good job, your only answer was A. Okay? Alright, from here on out, the next couple of ones, I'm gonna do as much as I can with you before the bell rings, and whatever problems I don't do, which means you gotta go online, look at the video, I want you to do for homework. Okay? So, this first one. To solve this, I cannot get 3 and 7 to have the same base. There's no way possible to do that. So instead of doing that, we're gonna take the log of both sides. Well, no, you don't change to the log form. You literally take the log of both sides, meaning you do log of 3x equals log 7. Now, both of these logs have a base of what? 10, which means I'm able to do it in my calculator because it does say round to the nearest 100. But I have this x here in the exponent. How do I get it out of the exponent? What do I need to do? Move it to the front. So this becomes x times the log of 3 equals the log of 7. To get x by itself, what do I need to do? Divide by log 3. So I'm going to type into my calculator the log of 7 divided by the log of 3, and that will give me my answer for x. Confirmation? There we go. That's how you do those. These are the ones when you cannot write it so that it has the same base, okay? You can take the log or the natural log of both sides. Right now in your calculator, do ln of 7 divided by the ln of 3. Do that. Do you get the same thing? Sure do. So it works. So say you forget and you did ln's instead, it still would work, okay? So, all right, so again, certain problems are going to be done by me, and then other ones are going to be for your homework. So here we go. You're going to solve this one. Since you have an e, you already know that you're going to have to take the ln of both sides to get rid of that e. Okay? By taking the ln of both sides, that cancels out, and you're left with 2x plus 1 equals the ln of 8. Then it's nothing but a couple simple algebra steps. You have the ln of 8 minus 1. Divide both sides by 2, and this is exactly what you type into your calculator. Being very careful that if you decide to type this entire thing into your calculator, you have to put parentheses around your numerator. So we'll have the ln of 8 minus 1, divide that by 2, and you'll get about 0.540 if you round to 3 significant figures. Oh wait, no, it says round to the nearest 100, so it'd be 0.4. Okay? 0.54. This one you're going to do for homework. So pause the video, write it down, and then so you can get it down so you can do it for homework. Over here, these ones are a little bit more involved because you have an expression in your exponent. But you still go about it the same way. You take the log of both sides because there's no way that you can rewrite 3 or rewrite 2 so that you have the same base. And by doing that, it allows your exponents to come to the front, just like before. And then what you can actually do with your log of 3 and your log of 2 is you can distribute it to both terms that are in the front. And you'll actually have to do that because in order to solve for x, you have to get your x's on the same side. So what I'm going to do is I'm going to add 4x log 2 to the left and add 3 log 3 to the right. And since both terms have an x in common on the left, I'm going to factor that out. And when I factor that out, that's going to allow me to divide both sides so that way I can get that way I can get x by itself. So I'm going to end up dividing this entire expression by 6 log 3 plus 4 log 2, and this is what I'm going to type into my calculator, what you see right here, okay? This is going to get typed into my calculator to get an answer. And I'm going to do that for you guys so you guys can see, okay? Might be some switching back and forth, but here we go. It's going to be 4 log, forgot already, 4 log 2 plus 3 log 3. That's all in my numerator. That's why I include the parentheses right here and here. Then I'm going to divide that by, in parentheses, that's 6 log 3. So 6 log 3 plus 4 log 2. And so my answer is going to be 0.648. I think I'm rounding to the nearest 10th, right? So it's going to be 0.65. All right. This This one you're going to do for homework. This one. All right, so for this one's a little bit different. But if you take a look at it, it kind of looks almost like a quadratic, doesn't it? Okay, like this is your x squared minus x minus 2. Well, this is exactly how you treat this problem. You treat it like a quadratic. You factor it. What two numbers multiply to give you a negative 2, add together to give you a negative 1? Well, that's negative 2 and positive 1. But instead of putting an x in these two places, you're going to put an e to the x. Because when you multiply e to the x times e to the x, you get an e to the 2x because you add your exponents. And then, of course, you get a negative e to the x when you do your inner and outer terms. So then you set both equal to 0. And you'll see that e to the x is going to equal 2. E to the x is going to equal negative 1. Now to actually solve for x, these are like two mini exponential equations. Take the ln of both sides. The ln of b goes away, so x equals the ln of 2. Over here, when you take the ln of both sides, the ln of e goes away, you just have x equals the ln of negative 1. But hopefully you remember that you cannot take the natural log or the regular log of a negative number, meaning that this one is not a solution. The only solution you have is the ln of 2. Okay? This one you're going to do for homework. And actually, you're going to do this one as well for homework. This one. And this one as well. Okay? So you have 6 problems that you're going to do for homework. So make sure you write them down, give them a try, and bring your questions to class, to next class. Okay? So those are your problems for homework. Here's 1, 2, 3, 4, 5, and 6.